Okay, welcome back. Okay, so this is what we've got so far. We've got the proof. We want to prove that f of x is equal to 1 over x squared, 1 over 1 plus x squared is uniformly continuous for all epsilon greater than 0. We choose a delta, but we got to figure out what that is first. Then for all x and z are elements in set S, such that f of x, the absolute value of fx minus f of z is less than epsilon whenever z minus x minus z is less than delta. So this proof part is kind of like boilerplate. You're going to see basically the same thing over and over again. Okay, so from here, we go ahead and substitute in for f of x and f of z 1 over x squared, 1 over 1 plus x squared minus 1 over 1 plus z squared for f of x and f of z. So that's going to be the absolute value of 1 over 1 plus x squared minus 1 over 1 plus z squared. Okay, and so that's your f of x and f of z. Okay, does that make sense?
Yeah.
Okay, now we need to get a common denominator. So since this is 1 plus z squared, we're going to multiply 1 plus z squared over 1 plus z squared times that, and we're going to multiply, since this is 1 over x squared, 1 plus x squared, we're going to multiply 1 plus x squared over 1 plus x squared, so that we get a common denominator. Okay, does that make sense?
Yes.
Okay,
And
go ahead.
oh no, I thought that the second screen wasn't there, but I accidentally tapped your face, so then it went to the other screen instead of that.
Okay,
I just thought it wasn't up there.
okay. So, we distribute this 1, right? So this
Okay.
will equal to 1 plus z squared. But here we have to distribute a -1. So this will be minus 1, and so that'll be -1 times 1, that'll be -1. -1 times x squared, that'll be negative x squared. And all of that is under the common denominator of 1 plus z squared times 1 plus x squared. Okay?
Okay.
So the ones, they're going to cancel out, right? They're going to go to 0. The ones are going to cancel. They go to 0 because it's positive and negative. And so we get the absolute value of z squared minus x squared all over 1 plus z squared times 1 plus x squared. Okay. And
Okay.
so now we have a difference of 2 squares. So we can go ahead and factor that. So that'll be z minus x times z plus x z plus x. And so, and that's over 1 plus z squared times 1 plus x squared. And all that is within the absolute value. Okay. Okay, so now we can take this z, the absolute value of z minus x. Let's look at this for a minute. The absolute value of z minus x is the same as the absolute value of x minus z. Okay, does that So, and we want to do that because eventually here, where we have x minus z is less than delta, we're going to replace that with delta. So that's why we switch these. Okay, so we can split this to where we have z plus x absolute value over let me use black. That way I can use red for like the side things. So this will be x minus z times x plus z, whether it's z plus x or x plus z, adding is commutative, addition is commutative. So that's 1 plus z squared is 1 plus x squared, and all that is absolute value. Okay. All right, so all I did was I just took this z minus x or x minus z, and I just pull it out. Okay, I just moved it off to the side. Okay, now I'd mentioned the triangle inequality. Let's look at this for a minute. Here we have one vector, we'll call that vector x. And we have another vector here, we'll call that vector z. So the magnitude of vector x and the magnitude of vector z together give us magnitude of x plus z. Okay, so does that make sense so far?
Yes.
Okay, so using vector addition, right? So therefore, this side, one side is always going to be less than the sum of the other two sides. So we can say that the magnitude of x plus z is less than the magnitude of x plus the magnitude of z. Okay.
Okay.
So this side is going to be less than magnitude of x plus magnitude of z. Okay. So having said that, we can split this and say that this statement here is less than magnitude of x over 1 plus x squared z squared, 1 plus z squared, plus the absolute value of z over 1 plus x squared, 1 plus z squared. And all I did is I took this absolute value of x minus z and I moved it over to the right. Okay.
Okay.
So this sum is less than absolute value of x plus absolute value of c, the two separate sides. Okay. All right. So now let's look at these for a moment. Let's see if we now we want to simplify these. Okay. And
Okay.
so we know that with fractions, right, 2 is less than 3, right? But 1/2, but when we put these numbers in denominators, 1/2 is greater than 1/3, right? The larger the denominator, the smaller the fraction. Okay.
Okay.
So in that case, we can say that the absolute value of x over 1 plus x squared. I need room. Absolute value of x over 1 plus x squared, 1 plus z squared, okay, is less than absolute value of x over 1 plus x squared z. Let me make sure I'm doing this right. Yeah. So if we drop the z, right, we can say that because this is a larger denominator, right, if this was 1x over 1 plus x squared, and this was 1 plus 2, right, so 3, right, so in other words, if this was x over 3, and this was just x, this would be smaller, right? So if we drop the z, drop the z squared, we can say that this expression is less than this one. So therefore, we can say that this expression is less than the absolute value of x over 1 plus x squared. Okay, this expression, because it has a larger denominator, is smaller than this one. Okay, does that make sense?
Yes.
Because this is 1 plus z squared. If we drop the z squared, it's just times 1, right? So because the denominator is smaller, this number is larger. The larger the denominator, the smaller the fraction. And so we can do the same thing with the z's. Okay, and if we drop the x squared, then this expression, then all of this is less than if we just had z over 1 plus z squared. So we're going to drop the x squared. Okay, and so this will be the absolute value of z over 1 plus z squared. Okay, all right, so from here, we can say from this, let's look at this for a moment. From here, if we had, if we were to say that if we were to say that x is less than or equal to 1, then we can say that the x, absolute value of x over 1 plus x squared, is also less than or equal to 1. Because here, this is going to be smaller, right?
Yes.
So we can say that we can say that 1 over 1 plus x squared is, we can say that this is less than 1 over x squared. Absolute value of x is less than or equal to 1 over 1 plus x squared. So Therefore, we could say that this is less than 1. Okay. And so from here, we can go ahead and say that from here, we can say that x over x squared plus 1 is less than 1. And z over 1 plus z squared, we still have, we don't want to forget this x minus z here. So we still have this x minus z here included in all this. So we want to make sure that's in there. Okay, so this all becomes 1, this all becomes 1. And so we end up with 1 plus 1 times x minus z, absolute value of x minus z. And so we get 2 times the absolute value of x minus z. And we said before that x minus z is less than delta. Okay, we said before that x minus z is less than delta. So this statement will be less than 2 delta. And since all of this, what we started with was less than epsilon, then we can say that this is the 2 delta is less than epsilon. Okay, and so if we divide by both sides by 2, we get delta, we're going to choose a delta equals to epsilon over 2. Okay, so from here, we're going to put that in here. So this will be epsilon over 2. And then we're going to go back and go through this whole thing again. And so substitute our functions in, get a common denominator, cancel out the 1s, and then get z squared minus x squared, and factor, take out the x minus z because that's going to be delta, and you could even put delta in here too. And then you use the triangle formula from there. Okay, so that makes it less than absolute value of x over x squared plus 1 plus z squared. And then you can say that this is less than if we drop the z squared. And this is less than if we drop the x squared. And so another way to look at this is we know that x over x is 1, right?
Yes, sir.
So x over x squared, if we don't even use the 1, that's going to be less than 1, right?
Yes.
So so that's why we can change this, and we can say, okay, all this, we can make all this less than 1 and all this less than 1. Does that make a little bit more sense?
Yes.
Okay, so we can change that to 1 and change that to 1, and then that's where we get the 1 plus 1, and then is times x minus z, and then change the x minus z to delta, and then divide by 2. And so from here, but once you get to this point, okay, once you get to here, you can say that since we chose delta is epsilon over 2, right? then from here, you can substitute epsilon over 2 and for delta, okay? And the 2's cancel and you get epsilon and you've proven it, okay?
Okay.
So that shows, that proves that f of x minus f of z is less than epsilon because we get epsilon in the end. So that's why it's important to go through all this and end up with epsilon on the end, because then that means that we've proven that f of x minus f of z is less than epsilon, because we go through all that and we get epsilon. So we've proven it, okay? Does that help?
Yes.
Okay, so yeah, go through these videos and so basically I just restated what was on the video, but maybe I'm hoping that maybe, you know, going through this live may help more than just watch the video.
Yes.
Does it help, or does it make any difference? Does it make any, how does that?
It's just an add-on. It doesn't like take away from it or anything. It's just like an add-on. So like I get more,
Okay. So you see
more
it again
about
and kind of starts to get more familiar.
Yes.
Okay, good. That's the whole idea. The more you see it, the more familiar with it's. This stuff is tough at first. It takes a while to pick up on it, but once you start to pick up on it, then it becomes easier and easier and easier.
Yes.
Okay.
Okay.
All right. So I think that's enough for today. I was going to go into the next lesson, but I think I'll wait on 3.6 and do that on Tuesday. And then that'll be it. 3.6 will be the last lesson.
Okay.
So take a look at the videos at 3.6 and we'll do some lecture time on 3.6, and then after that it's just review and get ready for the test and the final and all that. Okay.
Okay.
All righty. So Tuesday will be the last lecture, and then we'll start reviewing. So unless you feel comfortable to go into 3.6, I don't know. I'm going to leave that up to you. What do you feel? Do you think you're ready for 3.6? You want to kind of work?
No, not yet.
Okay, so you want to work on 3.5 first. I don't blame you. So yeah, go ahead and do that, and then we'll meet again on Tuesday. All right.
Okay.
Okay.
Have a great day.
Yeah, you too. Thanks. And we'll talk to you next time. Let me know if you have any questions. Okay.
Okay.
All right. Bye-bye.
Bye-bye.